We'll proceed in pseudo calculus problem. Okay, pseudo calculus problem idea is to take different examples and how we solve it through calculus. Okay, we take different examples and then we see how it can be solved through calculus. Okay, that is not the only aim. Other aim is to understand why we use calculus. This is not a preparation of preparation of competitive examination. Rather than it is something that we will take example by example, but we will also understand that we need to use calculus. Okay, this is x-axis, this is origin, and this is x-axis. Okay, so this is origin and this is x-axis. Now in that fashion, we have x-axis divided into many parts. One is x1, one is x2, one is x3. I mean, it is all right. This is origin and this is x-axis. Now origin to some point, the distance is x1. From that point to another point, distance is x1, x2, x3, x4, x5, something like that. Now, if I take 0 to any point x, then 0 to x is now distributed among x1, x2, x3, x4, x5 up to xn, where n tends to infinity. Means it is very small. Each section is very small. How I can write it? X can be written as x1 plus x2 plus x3 plus x4 up to n, where n tends to infinity. Okay, this is called addition. Loosely we can say repeated addition. Why it is not repeated? Because x1, x2, x3 may not be the same, but more or less it is analogous to repeated addition. It is analogous to repeated addition. X equal to x1, x2, xn, where n tends to infinity. Okay, now we know what is y into x. What is y into x? Okay, in that fashion, we have understood that there are two ways where integral calculus, I believe, okay, there are where we use integral calculus. Okay, so question arises is where we use integral calculus. Integral calculus we use where we need to have multiplication. There integral calculus we need to use. Where else we need integral calculus? Repeated addition, there also we use integral calculus, more or less. Repeated addition is multiplication, that's true. But the addition what we are talking is not actually the repeated addition. Like, okay, I believe it is understood. One is multiplication and one is addition. Both can result into integral calculus. This is what we are talking. Multiplication means y into x, y into x, where y is function over x, y into x, where y is function over x. Okay, y is function over x and x is one of the operand in the multiplication. Y is function over x and x is one of the operand in multiplication. In that fashion, y into x can be rewritten as fx into x, function over x into x, where x has some distance. X is from 3 to 10. After all, we are calculating area. What are you trying to do? We are trying to, I'm sorry, after all, we are trying to calculate multiplication. Multiplication of two entities. One is function over x into x. Function over x into x. Where function over x, it represents the height. If I multiply two items, it gives one kind of scenario of a surface area. Surface area has two sides. A surface area has two sides. Okay, if I say that I have a surface which has one side is x and another side is y, then there is an abstract area, not the straightforward. Abstract area, that is called y into x, where y has some amount and x has some amount. If I multiply these two, it gives the surface area. Why I said abstract surface area? Because y and x, they will constitute a rectangle when y is independent of x. Otherwise, if y and x are tied to each other, when x is changing, y is changing accordingly. In that fashion, they may lead to infinite number of 2D shapes, infinite number of 2D shapes. If y is tied to x, if y is not tied to x, then it will make a rectangle where x is the width of rectangle and y is the height of rectangle. Anyway, fx into x, y into x will become fx, small f, braces, x, braces close, function over x. Y into x would become function over x into x. Okay, if this kind of multiplication happens, where first one is fx and another one is x, function over x, and we are trying to multiply here, then this is a pure case of integral calculus. This is not normal multiplication. What are you talking about integral calculus? This kind of multiplication fx into x will be settled down only when we draw a graph. Any multiplication can be settled down in two fashion or rather than one fashion, that is called repeated addition. If I say y into x, that is as good as y plus y plus y plus y plus y plus y plus y x time. Y into x means y is repeatedly added x time. That become y by y into x. Okay, if y is function over x, then fx into x is not fx added repeatedly x times. If I say 5 into 3, 5 is added to itself 2 times, 5 into 2. 5 into 10, 5 is added to itself 10 times, 5 plus 5 plus 5. This is typically called repeated addition. So whatever multiplication we see, multiplication is solved through two ways. One is repeated addition and another is through area. Through area also, we can solve the multiplication. 5 into 2 is same as if I take a rectangle, one side is 2 and one side is 5. How much, what is the area of this rectangle? That also gives the multiplication. Another is keep adding 5 to itself 2 times. Okay, means y into x is same as y plus y x time. That is also multiplication. Another multiplication is draw a rectangle and in that rectangle x is width and y is height. That is also, that area is also multiplication. Okay, now take one small square with side 1 and 1. Area is 1 square. Take a small square. Whatever y by x area is there, fit those squares here. Fully fit it in the rectangle. Now count how many squares are there. If you count how many squares, that is the area of the rectangle. This way also we calculate the area, I mean the multiplication. So multiplication is calculated either through repeated addition or through area computation. If we are forced to calculate multiplication through area computation, then this is called integral calculus. That's it. That's it. That's it. What is integral calculus? If we are calculating any multiplication, dependent or independent, any multiple y into x, rather than going for repeated addition, If I take a shape, if I take a rectangle x into y and place one square meter or 1 square unit of rect, uh, 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 one square, one square, a square with one and one side. If I keep placing inside a rectangle and then count how many there, that is the area of the rectangle. We can find. If we are trying to solve any multiplication of two items through calculating the area of the shape, this methodology is called integral calculus. Sorry, sir, integral calculus is very high class thing. This is the integral calculus. Integral calculus is calculating the area by calculating the multiplication through the area fundamental. That is also that is this way is called integral calculus. Means if I am trying to calculate multiplication of two items and then I draw an area and find the area, that is integral calculus. Yes, that is integral calculus. Consider y into x, and y is function over x, and function over x is x. X into x will not be x square. Okay, if this is x axis, then y is expected as height, but height is x. When x is 0, height is 0. It is completely tied with the x axis. Y and x are completely tied to each other. In that fashion, y equal to x, that is a function that it will make a line like this rather than horizontal line. Now, y into x multiplication will happen 1 by 2x square. There is another way also. This is one scenario. Calculating multiplication through area. This is called integral calculus. Okay, y is constant. Y is not dependent upon x. Who said it is dependent upon x? Y equal to 5. 5 into x. Now tell me. Yes, you can calculate through area only. This is x axis and this is 5 constant. But it will be 5 into x. I know it is 5x, but calculate through your integral calculus. 5 into x through integral calculus will be 5 dx, where x is from 0 to x variable. 5 dx. 5 I can keep outside, dx will become x. 0 to x, 5x. Okay, means this looks like integral calculus is superset of multiplication. Very much true. Any multiplication we can blindly write in integral calculus. Any multiplication. Because we are trying to calculate multiplication through area way. There is another area where multiplication one area is multiplication can be solved through area way through integral calculus. Another is addition. What addition can be solved through integral calculus? I know addition is just multiplication. 2 plus 2 plus 2 plus 2, 10 times, right? 10 into 2. I'm sorry, 2 into 10. 2 into 10. That's what I write. Okay. Now consider this is x-axis. And then we have the x-axis and we have a small section on x-axis. One section is 2. One section is 2. 2 plus 2 plus 2 plus 2 plus 2, 10 times. Now I can write as 2 into 10. 2 into 10. 2, 10 times. What about if I have one section at x1, one section at x2, one section at x3, one section at x4, one section at x5, last section is xn, last section is xn. Okay, now add this. Okay, x1 plus x2 plus x3, where n tends to infinity. N tends to infinity means x1 is very small. X1 is very small. Someone can write it delta x1 to make facilitate understanding. Delta x1 not required. Someone can say x1 only. X1 plus x2 plus x3. Xn, where n tends to infinity. What is this addition? Someone can tell. If this kind of, now I cannot write x into n. X into n. This is not repeated addition. If I represent one small section as delta x, delta x1, delta x2, delta, thinking it is very small. Delta x1 plus delta x2 plus delta xn is not delta x into n. This is summation of I is I equal to 1 to n x I x, and I believe the bottom right side, I believe it is called superscript or something like that. Okay, in that fashion x and bottom right side I, where I is summation of I is from 1 to n, x1 plus x2 plus x3, where n tends to infinity. I have divided into many sections. This can be written as dx, where x is 0, x is 0 to x. But this is how it is. Integral calculus, integral calculus also represent more or less repeated addition. No. But I want it up to 0 to 100 only. Then write integration 0 to 100 dx. What is dx? Dx means delta x. What is delta x? That is delta x1 plus delta x2 plus delta. No, I don't want delta. Write it x1 plus x2 plus x3 up to xn, where n tends to infinity. If you have this kind of scenario, this repeated addition can again be written in integral calculus. Hope. One is y into x, that I can write as y dx, where x is from one limit to another limit. Similarly, this is multiplication transformed into integral calculus. We are trying to calculate multiplication through area. Wherever integral calculus comes, area, area way. Okay, that is one form. Y into x can be changed into y into dx. It will become integral calculus. Means you are trying to take area root to calculate the multiplication. These explanations are not available in any of the book. All are behind some English author only. Okay, and then people start 99.99 what I say, 1 in 1 million understand calculus. Otherwise, no one understands calculus, whatever it is. They just mug up. But calculus is this much simple one. That's it. Okay, if I'm trying to make repeated addition turns into multiplication, which turns into integral calculus. That is true. But repeated addition may not be the same section we are thinking, x1 plus x2 plus x3, where x1 is not equal to x2. But if I talk in infinite numbers, x1 plus x2 plus x3, xn, where n tends to infinity, and these sections they represent x-axis from 0 to 10, I can write integration 0 to 10 x1 plus x2 plus x3 xn as dx. What are you trying to say? You are trying to say that summation I believe sigma, right? Summation sign I equal to 1 to n, where n tends to infinity, xi, is it same as integration from 0 to whatever limit we are saying, dx? Exactly, same thing. Means addition, repeated, more or less repeated addition of sums of all subsections along a line will become integral calculus. This is what you are trying to say. Certainly, this is what I am trying to say. Anyway, we are in phase of calculating the area of a rectangle. We are in phase of calculating area of a rectangle. How we calculate the area of a rectangle? Okay. Let's divide rectangle the way you are saying. Thank you very much. Okay. What is area of the rectangle? This is radius and this is circle. Area of a circle. This is radius and this is circle. This is x-axis, this is y-axis. This is x-axis, this is y-axis. Radius and theta are not related to each other. What do you mean by not related to each other? Related to each other, dependent, independent. What are these? Okay, if this is the radius and if I move the radius along the theta, the way I am moving, it is making angle. If this is the radius is up till here only. This is not radius. Up till here. If this is the radius, and radius I start moving like this, it start making angle theta with the beginning position, commencement position, and then angle theta. Theta grows and it come to 90 degree. Okay, then theta goes to 180 degree, and then theta goes to 270 degree, and theta comes back to 360 degree 0 degree. If radius moves like this, then anyone can see theta is changing. Theta is 0, but theta starts changing. The angle starts changing. But radius size is same. Radius is not changing. Okay, but radius will never change. Radius will change. It's not that radius will never change. If radius changes with the movement of theta, then radius is dependent upon theta. If radius is not changing, if I am changing theta, then radius is considered as independent of theta. Okay, I can say I have a circle with radius equal to 1 and theta. Means theta varies from 0 to 360 degree, where radius is always 1. Okay, in r theta plane, what is r theta plane then? This is xy plane. Circle is in xy plane. This is x axis, this is y axis. Now in xy plane, if I talk about r and theta, then r will start moving and theta will change when r is constant. There is another orthogonal component, another coordinate system called r theta or polar coordinate system, where this is theta and this is r. Now theta will vary from 0 to infinite, 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on. But radius will be always 1. It is not, it is forming a rectangle. Okay, what is the area of the circle? If I take polar coordinate, then it is area of rectangle. Not necessary. Okay, we are trying to find area of a circle that is formed in Cartesian coordinate system. Okay, I have theta and r, they are independent to each other. If I take r theta plane, they will form a rectangle. That is true. But calculating the area in r theta plane will not give the area of the circle. That is for sure. We will see this. Anyway, what is area of the circle? Area of the circle, any novice person will come, oh, I don't know what is area of the circle. Area of the circle is length into height. No, 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 that will not work here because the height is not constant, it is variable. If I take x axis and this is the height, then height varies everywhere. So area is height by width, I cannot take. What is other way? I can take, but that will be abstract area. I just say y into x is area, then that is abstract area. You have to unfold it. It is not that straightforward. What is your straightforward? Okay, the straightforward is anyone would think now. Now let's divide this circle into many sections. This is arc. This is an arc. Let's take a radius, two radius. We have demonstrated in the past video. Let's take two radius. Make sense? Now it forms a closed region. The closed region is this arc between two radius and one radius. This is the closed region. This is the area. Consider this area is A1. Now keep this here and take another area. A2. Keep this here and take another area. A3. Keep this here and take another area. A4. Okay, like that divide the circle into so many closed areas. What is area of the circle? A1 plus A2 plus A3 plus AN, where n tends to infinity. Hope. Whatever we have taken this triangular region and this or a wedge, someone can say it is a wedge. That is a better word. Wedge. This is a wedge. Like birthday cake, people, that is comes as cylindrical shape. If you cut it, that will become a wedge, where two sides will be flat straight line, where end will be a curved line. This is a wedge. So area of wedge 1, wedge 2, wedge 3 up to AN, that is wedge number 9, wedge number N, where N tends to infinity. Now calculate the area of circle. Okay, understood. Now the concept coming is, can I write A1, A2, A3, AN as DA? Because this is what you said, right? Means if there is a repeated addition kind of thing, then can I write a1, a2, a3 up to an and n tends to 0 as summation of I equal to 1 to n tends to infinity ai. That will be area from 0 to a, whatever it is, 0 to a, and then dA, small d and capital A, dA. This will give the area. Anyway, it will give the area, that fashion. Okay, this is called pseudo area. But we converted our area, all area into integral calculus. Let's break it now. What is one area? This is what we were calculating. What is the one area? One area, if I calculate here, then angle between it is theta. This angle is theta. If this angle is theta, then what is the area? Okay, from here at this point, I'll take a tangent. If I take a tangent at this point, then this tangent it is exactly 90 degree from the radius line. And this tangent would go and bisect this line. This is tangent now. This triangle area is R1, R2, R1 into R2 by 2, because this will form this is half of the rectangle that is formed. I'm sorry, I'm really sorry. Okay, what is the area of this triangle? This line into this line that is a tangent line. Height into width, height into width by 2. If I say height into width, it will give area of a rectangle. This is a rectangle. Height height into width by 2 will give the area of a triangle that is that is half of this rectangle. This is the hypotenuse of that rectangle. Mind it that hypotenuse what we are talking here is this line that is up till here, not till radius. Radius is from here to here, but we are talking about a line up till here because tangent will go and hit there. So if I'm talking about the actual hypotenuse of the rectangle, the line that cutting the rectangle in two parts, this is rectangle. One side of rectangle is this, and one side is this. Full rectangle will be like this. Okay, in that sense, this becomes hypotenuse. Hypotenuse is from here to here plus something. Now, since this angle is very small, this is not theta d theta, very, very small, very, very. This is what I don't like. Tends to 0. But for time being, take it like that. Tends to 0. In that fashion, this tangent will become exact more or less along this arc. This arc length is this is r, then this arc length is r theta. So the area of this triangle, more or less triangle now, is 1 by 2 r, that is radius, into r theta. Makes sense? It becomes 1 by 2 r square theta. What is the full area? Now it is 1 by 2 r square theta 1 r square theta 1 plus 1 by 2 r square theta 2 plus 1 by 2 r to r square theta 3 up to 1 by 2 r square theta n. That is summation I equal to 1 to n 1 by 2 r square theta I, where n tends to infinite. Now r is constant, r is not variable. R I can keep outside. 1 by 2 r square summation of I equal to 1 to n theta I. This is exactly can be transformed in integral calculus as integration of d theta. Okay, thank you very much. But theta, now consider theta is one like x-axis. The way we said x-axis is broken into x1, x2, x3. Then it is any x-axis I can break into x1, x2, x3 up to xn. And now this x-axis I have a length 0 to 10. Means 0 to 10 is divided into x1 plus x2 plus x3 up to xn, where n tends to infinite. Okay, in that sense, x1 plus x2 plus x3 up to xn equal to 10. This left side can be written as summation of I equal to 1 to n, where n tends to infinity, xi. That can be written as integration of dx, where x is 0 to 10. Now, here, similar fashion, this this is this theta, the theta angle, the angle looks like variable here, and this theta angle is broken into theta 1, theta 2, theta 3, theta 4, theta 5, up to theta n. Okay, what is the total angle? That is 0 to 2 pi. We are calculating for a circle, right? 0 to 2 pi means theta 1 plus theta 2 plus theta 3 plus theta 4 up to theta n, where n tends to infinity. This summation is equal to 2 pi. The left side will become summation of I equal to 1 to n, where n tends to infinity, theta, theta, I. This will become integration of d theta. Okay, integration of d theta, where theta goes 0 to 2 pi. Makes sense? Now our calculation becomes 1 by 2 r square d theta integration from 0 to 2 pi. I believe it is all right. Now in that fashion, it will become 1 by 2 r square 2 pi, 2 gone pi r square. Pi square is the area of this circle. This is another region in addition to multiplication turning up into calculus, because we take a path of multiplication calculating the multiplication through the area fundamental. Repeated addition also takes the path of integration. I believe it is all right. Okay, now but indirectly, repeated addition indirectly takes path of multiplication indirectly, and then it becomes integral calculus. At the end, integral calculus is representative of multiplication by calculating the area of a 2D shape, where one side is one operand of multiplication and one side is another operand of multiplication. This is the basic concept of integral calculus. Repeated addition, indirectly it comes to multiplication phase only. This form of integration, what we talked now, it is heavily used in artificial intelligence, mainly in the Bayesian theorem. Everywhere neural network, Bayesian theorem means NLP, natural language processing, everywhere heavily used integration, that is repeated addition. Okay, thank you very much. Now the time has come that can we prove that area of one sub-rectangle 1 by 2 r square d theta. This is what we have taken, right? For one triangle, if I take, then area of this triangle, that triangle is 1 by 2 r square d theta. The theta is angle. Because we made an approximation that if theta is very small, this arc will behave like a tangent line. That is an approximation. Can someone really prove it? That a small angle is 1 by is the that the for one small, it is 1 by 2 r square d theta. Can someone really prove it? That is the question mark. This I can leave for an assignment now. This assignment, can someone really solve it? That one small rectangle, one small triangle that we have taken, that area is 1 by 2 r into r theta, where r theta is the arc, where actually I should have taken the tangent length rather than arc length. So this is the approximation. So anyone would know, he would interfere. Your base is wrong. If you take the area of one triangle as one side is radius, then other side you have to take the tangent length, not the arc length. You have taken r theta. That is wrong there only. Okay, can we prove that area of that circle, that triangle, and arc length is r theta, and perpendicular line, the tangent line, both are same when the d theta is tends to 0? Can someone prove it? If someone really proves it, then it will give a analogy that it is correct. Okay, what is a hint out here? What is the area of a circle? Area of a circle is, if I take circle, I have taken in xy coordinate, Cartesian coordinate, whereas we are trying to calculate area through coordinate that is polar coordinate. The items that we have borrowed, that is r and theta, that falls in polar coordinate system. But x-axis and y-axis we have taken that falls in xy coordinate. We have done a hybrid model. If we do hybrid model, then area of any shape where if I have a position vector, then it is dp by dp area. Okay, what is area of this? That is the question mark. Area, if I'm trying to calculate area of this, anyway, I'll prove it. But area of anything, if I take p as position vector, then dp by dr cross dp by d theta into dr d theta, that gives the area vector dp by dr cross dp by d theta dr. We will talk more on it. Okay, means if p is xi plus yj in Cartesian coordinate system, x is r cos theta and y is r sin theta. dp by dr cross dp by d theta, if we calculate, it will come as r dr d theta. What is r dr? What is r dr? R square by 2. At the end we came as r square by 2 d theta integration. Makes sense? I believe it is alright. Where r is considered 0 to r or 0 to a, whatever it is. R square by 2, then integration d theta. R square by 2 integration d theta. Integration of d theta can be broken in theta 1, theta 2, theta 3, theta 4 up to theta n. That is the basic rule. That is error free. In that sense, it becomes 1 by 2 r square theta 1 plus 1 by 2 r square theta 2. Tup, 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 tup. Then area is summation of 1 by 2 r square theta 1 plus 1 by 2 r square theta 2, like that. If I am trying to calculate in that fashion, this means that this full area that is constituted by radius moving in 360 degree, I have made partition into many. One is theta 1, reverse fashion I am trying to prove. In that fashion, 1 by 2 r square theta, this is exact area of a triangle. 1 by 2 r square theta is same as 1 by 2 r into r theta. This is exactly area of a triangle, area of any triangle. If I make area, if I make, I threw it. If I make area of a triangle, this is base and this is the hypotenuse. If area of triangle where this is perpendicular, if this is perpendicular and this is base and and this is hypotenuse, what is area of this triangle? If this height is y and this base is x, then it will be y into x. This will make area of a rectangle. This is half of it. Y into x by 2. If I say I have one thing, something like 1 by 2 r square theta, you can break it into 1 by 2 r into r theta. This is area of a triangle, that is half of a rectangle, that is r into r theta. One side is r and one side is r theta. Okay, where the line that makes r theta is perpendicular to the r, the way we showed. This proves that if theta is very small, then I can take this tangent as r theta. Okay, and it happens to be the r. This is the proof. We will talk more on it by calculating the this is the another world. One world is multiplication is transformed into integral calculus. That is another world. This is another world where theta 1 plus theta 2 plus theta 2, theta n, where n tends to infinity, because d theta integration. Amazing, mind blowing. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.